Hello everyone, welcome back to Life Technologies YouTube channel, and thank you so much for watching and supporting our channel. So this is another episode of our Nokia Lab simulation series. Remember, in this series we discuss how to implement different networking technologies or different networking protocols on Nokia routing and switching devices. So if you are interested in learning how to operate and manage, how to troubleshoot, how to configure different networking protocols like OSPF, ISIS, BGP, MPLS, and many other protocols on Nokia routing and switching devices, kindly check out this series and have a look at it. We have a couple of videos that we have published in our previous episodes. So in this episode, we'll be discussing how to implement BGP route reflection on Nokia routing devices. So we know BGP stands for Border Gateway Protocols. It's a very common networking protocols. It's used almost in all networks, both service provider networks, both large and medium networks. So we call it the protocol of the internet because it's mainly used to connect service provider network to the internet, and also it's used within the service provider networks to ensure that we have end-to-end reachability between different autonomous systems. So BGP as a protocol has a mechanism that is used to control loops. We know that when you are running these protocols like OSPF, ISIS, BGP, you may end up having loops in the network. So you need some mechanisms that can be able to control loops in the network. All these protocols have their own mechanisms. For IBGP, we have the split horizon. So with the split horizon, whenever we have a route advertised from an IBGP peer, then the IBGP peer will not advertise the route to another IBGP peer. So you learn it from an IBGP, you don't advertise to another IBGP, you only advertise it to an EBGP peer. So we end up having some disconnect in the network, and you need to be able to control this scenario so that we have end-to-end connectivity or end-to-end communication between different networks. So you can see that in this topology, we have two autonomous systems. We have R1, R2, R3, R4, RR, and then R5. So we have two autonomous systems. We have a 65,000 that has R1, R2, R4, R1, R2, R3, R4, and the RR. And then we have autonomous 65001 that has R5. So we'll be configuring BGP, both IBGP and EBGP among and also between these autonomous systems. So with the split horizon, it means, for example, when we have R2 advertising a route to the RR, in the standard implementation, the RR will not advertise the route to R4, R3, and R1. The route will only be advertised to R5. So R3 will never learn routes from R2. And that's why we need to find a mechanism to have a workaround over this split horizon mechanism. So we have different implementation, we have different mechanisms that we can use. We have the meshed peering. So we have the BGP meshed peering where we do peering among all routers in the network. So if you have 100 routers, you end up having to have BGP peer relationship established among all these 100 peers. So every router will have 99 peers. So this one, the workload is too much. It's not good for a large service provider network. So it's normally used in a small network. Then you can use the meshed peering mechanism. We also have the idea of confederation where you are configuring sub-ASs within the main AS. So in this scenario, you can have R3 in a sub-AS, R2 will be in sub-AS, R1 and R4 can also be in their own sub-AS. So they will have to exchange the routes because the sub-AS will see another sub-AS as an external BGP. So they end up exchanging the routes, and then we have the routes propagated in the entire network. The best solution that is commonly used is the route reflection. So with the route reflection, we have a router in the network that is in charge of distributing the routes. So there is a specific router that we call the route reflector, and this router will be in charge of distributing routes in the autonomous system. So whenever an IBGP advertises the route to the RR will be in charge of advertising this route to all the other routers in that cluster or in that autonomous system. So in this setup, you can see that we have our RR, which is 1.1.1.1, mask is 32, and then we have the other routers, R1, R2, R3, R4. So whenever a route is advertised to the RR will be in charge of advertising the route to all the clients. So we have the clients and non-clients. So RR, all the other routers, R1, R2, in this setup, we'll have a different implementation. We'll have R2 and R3 being the clients, and then R1 and R4 will be non-clients, so that we can demonstrate how the route is propagated between clients, non-clients, the RR, and also to the external peerings. So this is the setup that we'll be using. We have mentioned that we have the two autonomous systems. We'll be using OSPF in 65,000. So that we have reachability, and then we use loopback 0 to configure the peering relationship between the different routers. Then we'll have to establish IBGP peering relationship between the RR and R5. So we'll have to configure OSPF in a 65,000, and then we can proceed with implementing the BGP peering sessions. So just a reminder that if you are enjoying this video, if you are watching this video and you are yet to subscribe to our channel, kindly hit that subscribe button and stay tuned for more upcoming videos, and also to support our channel. So to start up, of course, we need to do some basic configurations. The first thing that we need to do is to check the connections. So you can see that we have RR is connecting to 5 routers. So we have configured LLDP on these routers. So if I show system LLDP neighbor, you can see that we have 5 connections. These are the 5 connections on the RR. So R1, R2, R3 to R5. We can check on R1 to verify. Show system LLDP neighbor, we have 1 connection on C1. On R2, show system LLDP neighbor, we also have 1 connection. R3, show system LLDP neighbor, we have 1 connection to the RR. R4, show system LLDP neighbor, we have 1 connection. And then R5, let me reopen R5. This is R4, so I can open R5, R3 and R5. We have R3, I've already show system LLDP neighbor, we have 1 connection. And finally on R5, I've copied, don't need to copy. So R5, show system LLDP neighbor, you have a connection on R5 on RR on C5. So this one means that our physical connections are okay. So we can now start doing the configuration. The first step of our configuration will be to configure IP addresses on the interfaces. So we need to do IP address configurations on the system interface and also on the physical interfaces interconnecting different devices, the back-to-back connection between different routers. So we've demonstrated this before, but again, we'll do the configuration step by step so that we have a better understanding of how to do the configurations on the Nokia routing and switching devices. So if I show router interface, this one will tell us that we have the system interface, we don't have IP address configured. So we can start by configuring the address on the system interface. And the command is configure system, configure router interface, system, and then we assign address of 1.1.1, mask is 32. So we have configured. If I run show router interface, we expect to have it in the up state. The next stage, we can now configure the physical interfaces. So we'll start with the interface connecting to R1. So it's configure router interface to R1. Then we can give it a description to R1. It's always a good practice to give descriptions to your interfaces, and you give a very good description that can be used to, especially when you are troubleshooting connections in the network. Once we have given the description, we need to give it address. So it's address of 10.10.10.0, mask is 31. And then we need to to bind the port. So I can show system LLDP neighbor to get the port, and then its port, this is the port info. So you can see that yes, we have finished configuring that interface. We also need to configure router interface to R2. We'll give it a description to R2. Then we can bind the port. So port is, this is C2. And then we can give the address of 10.10.10.2 mask is 31 info. We can see the configuration that we have. So exit, we can configure the interface to R3, configure router interface to R3, and then we can give it a description to R3. Once you have given it a description, we assign the address of 10.10.10.4 mask is 31, and then we need to bind the port. So the port should be C3 info. So we have the configuration. Exit, we need to also configure the interface to R4 and R5. Configure router interface to R5 to R4 first, description to R4, and then address, it's 10.10.10.6 mask is 31, and finally we bind the port. So the port should be C4 info. We can verify the configuration, exit, and finally we can now do the configurations for R5 10.10.10.8. So configure router interface to R5, description, we give it just to R5, and then address, it's 10.10.10.8 mask is 31, and finally we give it the port. We bind the port of C5 info. We can exit, we can configure router info. We see the interface configuration. We have interface to R1 to R2 to R3 to R4 to R5, and then system. Show router interface. We have the 6 interfaces, including the system interface. So to R1 to R2 to R3, and you can see the details, the port, the address, the status, admin, and also the operational status, the mode. They are all networks. So once you have finished configuring interfaces on the RR, we can go ahead and configure interfaces on R1. Configure router interface system. We give it address of 2.2.2 mask is 32, and then configure router interface. We have interface to RR, address, it's 10.10.10.1 mask is 31, and we give the port is C1 info. Can give it a description to RR info. So we have the show router interface. We should be having the 2 interfaces in app state. We move to R2, we do the same. Let me reopen R2. So show router interface. So we have the system interface. Configure router interface to system. Address, we are giving it address of 3.3 mask is 32. Then configure router interface to RR, description to RR. We need to assign address of 10.10.10. This is R2, this will be .3, mask is 31 info. We need to bind the port info. So we have the interfaces, show router interface. We have the 2 interfaces. I will verify on R1. R1 we have .1, which is okay. So we move to R3. R3, same, show router interface. We expect to have the system interface without IP address assigned. So it's configure router interface system address. For R3, it's 4.4.4, mask is 31. Mask is 32, yeah. System interfaces only assign a /32 or a 128 for IPv6. So once we have done that, we can configure router interface to RR. We give it address of 10.10.10.5. Mask is 31. We bind the port, and then we give it a description to RR. Info, you see the configuration, exit, show router interface. So you have the two interfaces. Then we do the configuration on R4. Configure router interface system. This is 5.5.5, mask is 32. System, then address 5.5.5, mask is 32. And again, we need to configure the physical interface. Configure router interface to RR and give it address of 10.10.10.7, mask is 31. Port, still same port, and then description to RR. We can show router interface. So we have the interfaces. Finally, on R5, configure router interface system, and then we give it address of 6.6.6. Mask is 31. Mask should be 32. Configure router interface to RR. Address, it's 10.10.10.9. Mask is 31. Give it the port, and then description to RR. So we have completed the configuration of router interfaces. Show router interface on R5. We can go back to RR and test. So we can ping 10.10.10.1. We are able to ping 10.10.3. It's okay. 10.10.5.9.7, and finally .9, that is on R5. So if I run show router ARP, we expect to have the ARP. So this is the command that you use when you want to view the ARP. Show router ARP, you can see that we are able to learn the MAC address from the peer devices R1, R2, R3, R4, and R5. So we have completed the basic configuration, the interface configuration. The next step is to now configure OSPF in a 65,000 so that we have connectivity between different routers. So we need to configure OSPF. Remember, there are some few things that you need to specify when you are configuring the OSPF, like the router ID, the area, and then you need to activate it on the interfaces. So I will configure router OSPF 10. We'll give it a router ID of 1.1, the loopback IP, and then we need area 0. We can activate the interface system, no shutdown. Area 0 interface to R1, no shutdown. Then we can recall the same command. This will be to R2, then to R3, to R4. We only have to R4 because R5 it's IBGP, so we'll be using the point-to-point. So if I run info, you can see that these are the configuration. We need to no shutdown, info. So these are the OSPF configuration that we require. You can see that we have specified area 0 and activated OSPF on the interfaces. So we can do similar configuration on R1. We need also to configure OSPF, exit, configure router, OSPF 10, router ID, it's 2.2.2, and then area 0, interface system, no shutdown. area 0 interface to RR no shutdown. Info, we have the configuration. We need to enable the OSPF process info. So these are the configurations on R1. R2 we do the same. Exit configure router OSPF 10 no shutdown, area 0 interface system no shutdown. Then interface, we need to specify area 0 interface to RR no shutdown. And finally, no shutdown the OSPF process, router ID, it should be 3.3.3 info. So we have the OSPF configurations. On R3, we do similar configuration, configure router OSPF 10. Router ID, it should be, this is 4.4.4. And we can configure the area, but let me activate the OSPF first. Area 0, interface system no shutdown, and area 0 interface to RR no shutdown info. So we have the OSPF configuration. And finally on R4 we do the same, exit. So it's configure router OSPF 10, router ID, it's 5.5.5 no shutdown, area 0 interface system no shutdown, and area 0 interface to RR no shutdown. So we have finished configuring OSPF. We can verify our OSPF status. If I run show router OSPF 10 neighbor, you have neighbors to R1, R2, R3, and R4. So, and you can see the state is full. You can show router OSPF 10 routes. So we have learned the routes. We should be able to ping the loopbacks of the other routers. So ping 2.2, we are able to ping 3.3.3, that's okay. Ping, we can put the number of count, ping 4.4.4, count 2, just to verify, that is okay. Ping 5.5.5, count 2 packets. So we have the connectivity between different routers. So at this stage you have finished configuring OSPF on the routers. You can see the status, it's up on all the routers as verified. Show router OSPF 10 neighbor. You can also check the status of the interface, but in this case we have a separate episode that we discussed how to troubleshoot, how to configure OSPF. Whenever you are facing any issues troubleshooting OSPF, you can always check out those videos on this series. So once we have finished configuring the OSPF, we can now go ahead and implement BGP. So we'll start by configuring the BGPs on RR. And this is just the basic BGP configuration. We are not implementing the route reflection yet. The route reflection will come in the next step of our configuration. So I'll configure router. The first thing that we always have to do is to configure the autonomous system number. So I will configure router autonomous system number. This is 65,000. We can also configure router ID. Router ID, this is 1.1.1. So once we've done this, we can now go ahead and configure BGP. Configure router BGP. The first step, we can always create the group. So we create the group IBGP for IBGP peering sessions. And then we can configure the family IPv4 and VPN-v4. Local address, the local address that we'll be using to connect, we are using 1.1.1. Local AS, we've configured the autonomous, but we can still configure the local AS of 65,000 info. So we have the family, we have the local AS, we have the local address. The next stage is now to specify the neighbors, or we can, in this group, we can just peer AS. So the peer AS will be 65,000 because this is IBGP. So these are the configuration that we have so far. So we can specify the neighbors 2.2.2 no shutdown, neighbor 3.3.3 no shutdown, neighbor 4.4.4 no shutdown. When you are configuring the peering relationship, you can also give a description for the peers. So it's neighbor 5.5, 5.5.5 no shutdown, info to verify the configuration. So we have family. In this group, we have this peering relationship. Exit, we can verify the configurations again. So I will create another group, EBGP, for our external peering. In this group, again, family, IPv4, VPN v4. And then we can specify the peer address. Peer AS, it's 65.5. Let me verify, 65.0.0.1. And then local AS, it's still 65,000. I can specify the neighbor as 10.10.10.9. No shutdown, because we are using the point-to-point interface for the EBGP peering relationship. So exit, info, these are the configuration that we have. So we have our EBGP peering relationship. We also have our IBGP peering relationship. So we move to R1. On R1, configure router autonomous system number. We need to configure the autonomous system number to 65,000. Configure router ID, same as we did before. Router ID, this will be 2.2. Then configure router BGP, we get a group IBGP. Local AS, it's 65,000. Local address, it's 2.2.2. Info, you have these two lines, so we can go ahead and configure the peer AS 65,000. Info, and then finally we can specify the neighbor. So neighbor, it's 1.1.1 no shutdown. Info, exit, info. So these are the BGP configuration. If I show router BGP summary, you can see that our peering relationship is now up. Or we need to specify the family in that group IBGP, and then family IPv4. So if you don't specify, and then VPN v4. Info, show BGP summary. This is the command that you use, show router BGP summary. So you can see now that we have IPv4 and VPN v4 peering between these routers. So the next step is to configure R2. So for R2, we do the same configuration, exit, configure router BGP. Can even copy the configurations on R1. Because they are the same, so I will copy this, but we need to change the local address. So let me just configure one by one. Configure router autonomous system, it's 65,000. Configure router ID. Route ID for this router R2 is 3.3.3. And then configure router BGP, group IBGP. Family, we are IPv4 and VPN v4. We have local address, local AS 65,000, local address is 3.3, peer AS 65,000, info. We have all these configurations, and finally we can now specify the peer, the neighbor. So neighbor 1.1.1, no shutdown. Show router BGP summary. You can see that we have IPv4 and VPN-v4 peering relationship that is now up. We move to R3. So on R3, exit, configure router, autonomous system number, it's 65,000. Configure router ID. This will be 4.4.4. And finally, we need to configure the BGP configuration. Configure router BGP group. We have IBGP. Remember, it's always good when you are configuring BGP to implement the group, so that those repetitive commands will have to, you don't have to configure them many times. You just configure it once. So especially on the RR, you can see that we have multiple peering relationships. So we need to, with the group, we can be able to minimize the number of repetitive commands that we are using. So I will specify the family IPv4, VPN-v4, local address. This is on R3, local address it's 4.4, local AS it's 65,000, and then peer AS it's still 65,000. Info, we've specified the parameters, and then we run the neighbor 1.1.1, no shutdown. Info, exit, info. These are the configuration. Show router BGP summary. You can see that we have a peering relationship with 1.1.1.1. And then R4 we do the same. Configure router autonomous system number, it's 65,000. And then configure router BGP group, give it a group IBGP, and we go ahead to configure the peer AS 65,000. Local address it's set to 5.5.5. Info, family we have IPv4, VPN-v4, depending on the family that you want to configure. Info, and then can run neighbor 1.1.1, no shutdown. Info, exit, show router BGP summary. So you can see that we have a peering relationship that is now up. You can see that even without configuring, because we have already configured the autonomous system number, so the local AS is not mandatory. You can see that our peering relationship is up. So finally, we need to do the configuration on R5, exit, configure router BGP. We need to start by configuring the autonomous system number. Configure router autonomous system number 65001. Configure router BGP, and then we need to specify a group. So we'll do a group IBGP, and then local. No need to specify the local AS. Let me see, peer AS 65,000. Info, and then we need to specify the peer 10.10.10.8, no shutdown. Oh, this is peer AS. We need to specify the neighbor 10.10.10.8, no shutdown. Family IPv4 and VPN-v4. Show router BGP summary. So you can see that our peering relationship is up for the IBGP also. So with this, show router BGP summary, you can see that we have 5 peering relationship already established. Show router BGP. You can see many other details that you can check. You can even specify the group IBGP, and then you see the details, or you see the list of static peers. If you have list of dynamic peers, you can also see all those details. So with this, we have finished configuring the BGPs on the routers, and we'll do a route advertisement from one of the routers. So on R1, on R2, we need to advertise the loopback to BGP. So I will R2. Let's test with R2. So R2, we need to configure router policy options for us to be able to advertise this route. Policy options, and then I will create a prefix. We always need to begin. So this one we begin, and then prefix list. We are creating a prefix list of import loopback. Once you are with this, you can create a prefix. You can see the prefix. So we are merging 3.3.3, mask is 32. Exit, and then we are configuring policy statement, import loopback, import loopback. Can use a question mark always to. With this, we can create and return if match. Let me see, we have from protocol direct, prefix. From protocol direct, we need to merge the prefix list. From prefix list, we have import loopback. Then we are setting the action of accept. So we are only info. So we have from protocol direct, we are merging the prefix list of import loopback, and then the action is accept. Exit info. So we have our policy, and then exit. So if I show router BGP routes, you can see that we don't have any routes. Even on the RR, so we don't have any routes. Show router BGP routes, we don't have any routes. So on R2, we have the policy exit. So we'll configure router BGP info, and then export. We are putting the policy of export policy name. It's we configuring it on this router. Was it on R2 or R3? Show router policy. So we need to commit, exit, configure router policy options info. We need to do a commit here. Configure router BGP info. We configure export, import loopback. So now we have advertised this route to the neighbor. So if we check on this router, we expect to be getting the route. We give it some time. on R2 import info. So we are importing into BGP and then we are exporting it. Let me check on the RR. So we now have the route. You can see that we have a route of 3.3.3. So this is an IBGP relationship. So when the route is advertised from R2 to RR, we don't expect it to be available on R4. So we can check on R1 show router BGP routes. You can see that we don't have any routes, but we expect to have the similar route on R5. So on R5, let's see, show router BGP routes. It's not there. Let me see. Show BGP. Show router BGP routes. So we have the route. Let me confirm on RR. On R2 again, show router BGP routes. We have the routes on RR. Yes, the route has been advertised, but it's not being advertised to the other routers because of the split horizon mechanism. So what we need to do is to now configure our 1.1.1 as the route reflector and see if we are able to learn the routes from other neighbors. So we go ahead and do the implementation. So for us to be able to configure this router as the RR, we only need to do one thing. We'll go into the group IBGP info, and then we configure the cluster ID. So we need to configure the cluster, and we can use the loopback ID as the cluster ID. So info, so we have the cluster ID configured. Now the route has been advertised to the RR. We check if we can be able to learn it on this router. We'll give it some time. Show BGP summary. Show router BGP summary. Show router BGP neighbor 2.2.2. Advertise inactive, tracking, split horizon, disable. I'm checking whether we have the advertised routes. Prefixes counters. Let me see. Check on R1 again. Given that the loopback of this router is in OSPF, let's do one thing. Let's configure another loopback on R2 because that route is already in IBGP, so it may not be advertised to it may not be installed in the BGP table. So what we need to do, I will log into R2 again and create another interface. So configure router interface loopback 100. I'll call it a loopback, and then I'll give it an address of 100.100.100. Mask is 32. Info, so it's up. I can be able to ping 100.100.100.100. Configure router policy options. So we need to edit the policy options. Begin, and I will edit the prefix import loopback info, I will now prefix this prefix. I'll remove this prefix and I will get another prefix. So prefix 100.100.100.100 mask is 32. Info. Exit and then commit. So on RR, let's check show router BGP routes. So we are getting the route. You can see that we are getting the route 100.100.100. Are we able to get the route on R1? Show router BGP summary. Have the peering, show router BGP routes. You can see that we have the route. So for a clear demonstration of the split horizon, let me remove the cluster ID from this configuration. I will unknow cluster ID 1.1.1, just no cluster. So now we are getting 100.100 on the RR. Do we have the route in? We still check on the RR. So we'll check on RR. We need to verify that we are still getting the route. Show router BGP routes. We are getting the route 100.100.100, mask is 32. And we do one thing. We check on R1. R1, where is R1? Show router BGP routes. So you can see that we are not getting it. So the route is advertised from R2 to RR, but then with the split horizon, the RR doesn't advertise the route to R1 because it's an IBGP peer. So we check on R5, show router BGP routes. You can see that yes, this one has the route because the route came in from IBGP. It's only advertised to the EBGP neighbor. So once we configure this router at the RR, now the route will be advertised to configure router BGP group IBGP info, and we configure the cluster ID 1.1.1. So now we expect the route to be back on R1 because now the route is being reflected from the RR. We also expect the route to be in R4. Show router BGP routes. You have the route on R4. So the route has been reflected to both IBGP and EBGP peering relationships. And now, how do you make one to be an ANN client? For us to be able to make a router to be an ANN client, it's very simple. On this group, we can specify the neighbor. So we say that we have R1 and R4 will not be clients. So we can R4, R2, so it's 2.2.2. If you use the question mark, we have a command disable. So we disable client reflect info. Disable client reflect. This is a command that you use to make this an ANN client of this cluster. So once we go back to R2, the route was reflected from R2, so we can make R1. Let me check R1. You can see that now we are not getting the route because it's an ANN client. On R3, show router BGP routes. We still have the routes on R3. So this is the command that you use to make a router to be an ANN client to the route reflector. So we can also make, we have made router 2, we can also make R2, this is R1. We can also make R4 to be a non-client. So I will run the command neighbor 4.4.4. This is disable client reflect. So we have two clients and we have two non-clients. So if we were to also demonstrate one thing, is we can demonstrate if we are getting a route from a non-client. So we log into R4, where is R4, and do similar configuration. Exit, we'll configure router interface loopback 200. We make it a loopback, and then we give it address of 200.200.200.200. Mask is 32. Exit. Then configure router policy options. Begin info. So we have the configurations. We need to configure prefix. Import loopback. And then we give it a prefix of 200.200.200.200. Mask is 32. Info, it's exact. Exit, we configure policy statement. Import loopback. And return from protocol, from prefix list, import loopback. Action, so and return info action accept, and then exit. We need to commit. Exit again, commit. After committing info, these are the configurations. So we are just creating a prefix list and then a policy statement, a policy to export that route. So configure router BGP group. We can just export, import loopback, import. So with this, we expect that this one will be reflected to the RR. We can check the RR, show router BGP routes. You can see that we have 200.200.200 is coming in. So when we check on the non-client, another non-client is on R1. So R1, still the route not reflected, but let's check the client. Show router BGP summary. Show router BGP routes. R3, it's set to 4.4.4. Let me verify on RR. Info R4, so we check on R2. Show router BGP routes. You can see that we are able to get on R2. So the route is coming from non-client, but again, it's reflected to the clients. Can verify the configurations just to show you how to implement. So I mentioned that when you are configuring a route reflection functionality on Nokia router, the key command that you need to add is just to configure the cluster. Once you configure the cluster ID, then this will be the route reflector. We don't need to make any changes on the other routers in the network. Only the route reflector client has to be configured with this command. And if you want to disable some clients to be non-clients, you use this command, disable client reflect. So this one makes these two to be non-clients to the RR. I hope you've enjoyed this session and you've learned something. I hope we'll be having many other lab simulations on the Nokia lab simulation series. And if you are yet to subscribe, kindly subscribe to our channel, share the content, leave your comments in our comment section if you have any question, And again, just hit that subscribe button and stay tuned for more upcoming videos. Thank you again for watching and see you again in our next episode. Bye.